Okay, Chapter 5 is on statistics, and Section 5.1 is on exploring data. And statistics is the branch of mathematics that deals with the collection, analysis, and interpretation of numerical data. And the data can be collected from a population or a sample of the population. And if it's collected from a sample of the population, the sample for the statistics to be reliable, the sample should be representative of the population. So in junior high, I looked at measures of central tendency, which were mean, median, and mode. And mean is what most people refer to as the average, and what we think of when we think of as the average, and that would be to add up all the data in a set and then divide by the number of data values in the set. And the symbol that you can see a lot of times is this symbol here, X with a line over it. That means mean. That's usually the mean of a sample. Median is the middle of the data when the data are arranged in numerical order, and so if there's an odd number of pieces of data, it would be the exact middle piece of data in the set. But if there's an even number of data, the middle would be right in between two numbers, so you would just average or take the mean of those two middle data. And the mode is the most frequent data value in the set, the one that occurs the most often. It is possible to have more than one mode in a set of data, or no mode at all if there are no values that repeat. So all of these are basically referred to as measures of central tendency and averages, but the one that as I said earlier, the one that most people think of when they think of average is the mean. So in the first example here, now you're asked to find the mean, median, and mode for the set of data. So the mean would be simply to add up all the pieces of the data, so 12 plus 12 plus 18 plus 17 plus 14 plus 16 plus 15 plus 12 plus 19 and plus 10. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces, yeah, because it's representing the data, represents how long it takes in minutes for Sam to get ready on the last 10 mornings. So there's 10 pieces of data, and if you add those up, just add them up quickly. I'm getting 145 over 10, which is about 14.5 minutes. And the median, first we have to put them all in numerical order. So the lowest piece of data there I think is 10 minutes. So that would be 10, and then we have 3 12s. And then we have, just mark them off that I've put them down so everyone can see. So I got a 14 next, I believe, and then a 15, and then a 16, and a 17, and an 18, and a 19. I'm just going to add them up, make sure I got 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So we've counted for all of those. So then the median would be the middle piece of data. So there's an even number of pieces of data, and half of 10 would be 5. So 1, 2, 3, 4, 5. So this would be kind of the line that goes right down through the middle of the data. There's 5 pieces on the left of that line and 5 pieces on the right. So the median, because it's an even number of pieces of data and you don't have one middle piece, you take the average of 14 and 15, or the mean of 14 and 15. So 14 and 15 divided by 2 is going to be 14.5 as well. And the mode is the most common piece of data, which in this case, the one that occurs most often, is 12. Okay, the next question asks you to find the mean, median, and mode for each person, and these are the last 5 unit tests in Math 2201 for 2 different students. So for Tim, we would have the mean would be 60 plus 65 plus 70 plus 75 plus 80. all divided by, there's 5 pieces of data. So that would be 65 plus, 60 plus 65 plus 70, 75 plus 80 divided by 5 is 70. And then the median for this set of data, these are in order already, so if I just, rather than write them all out again, we just go up and look at the middle piece of data would be 70. And then the mode is the most common piece of data, which all of them only occur once, so there is none. And then if we look at Luke, his mean for his test scores was 68 plus 69 plus 70 plus 71 plus 72. And if you add all those up and divide by 5, you will also get 70. And the median, again his data is in order as well, 68, 69, 70, 71, 72, so the middle is this piece right here. Half of 5 pieces of data will be 2.5, so 1, 2, and then there's the one that's in the middle. So median would be 70, and again all the data pieces are unique, so there would be no mode. So if you look at both of those sets of data, they obviously have different numbers involved, but both sets had a mean of 70 and a median of 70 and no mode. But it's clear that they did score differently on their tests. So now we're going to look at the range for each set of marks, and the range, if you remember, is just the highest mark minus the lowest mark. So I'm just got to go back for 1 minute. For Tim that would be 80 minus 60, and for Luke it would be 72 minus 68. So Tim range was, the highest piece of data was 80 and the lowest was 60, so that's a range of 20 marks. But for Luke, was it? The range, highest mark was 72 minus the lowest mark was 68, so it's only a range of 4 marks. So what does a range tell us about the data? This tells us that Tim's marks are more spread out across a larger range of numbers. And also, I guess you couldn't say in this case, because both of them had a mean of 70, but Luke is probably a little bit more consistent with his marks, because his range was a lot smaller. It was very small. So his range of marks was really small, so a little bit more consistent than what Tim was. Tim's range was a little bit more extensive, 20 versus 4 for Tim and Luke. So range is a measure of dispersion, and dispersion is a measure that varies by the spread among the data in a set. A dispersion value of 0 would basically mean that all data in the set are identical, whereas as the measured dispersion increases in value, that means that the data is more spread out. Range is limited. Its use of range as a measure of dispersion is limited because it is only taking into account the highest and lowest values in the data. Later in this unit we'll look at a more complete measure of dispersion known as standard deviation, and that basically takes into account each individual score in the set of data. So right now we're going to look at an example, another example of data, and answer some questions on it. So it says, in a science experiment, students tested whether compost helped plants grow faster by counting the number of leaves, that should be leaves, on each plant. The following results were obtained. Plant growth without compost had 6 leaves, 4 leaves, 5 leaves, 4 leaves, 8 leaves, and 3 leaves. And the plant growth with compost had 6 leaves, 11 leaves, 1, 6, 2, and 4 leaves. So calculate the mean, median, and mode for each group. So without compost, we have the mean would be 6 plus 4 plus 5 plus 4 plus 8 plus 3, and there's 1, 2, 3, 4, 5, 6 pieces of data, and the mean, not much room here to write, is there? 15, 19, and 8's 27, 30 divided by 6 is 5, and the median, we would have to put these data in order first. So there's a 3, and then 2 4s, and then a 5, and then a 6, and an 8. So the middle piece of data here would be the average of 4 and 5, or the mean of 4 and 5, which would be 4 plus 5 divided by 2, which is 4.5. And the mode would be equal to 4 for the without compost, and the with compost, we have the mean would equal 6 plus 11 plus 1 plus 6 plus 2 plus 4, all divided by, again, 6, and that would equal 17, 18, 24, 26, 26, and 4 would be 30 divided by 6, which is also 5, and the median, we'd have to put those in order again, which would be 1 and 2 and 4 and 6 and 1, 2, 4, 6 and 6 and 11. And there are 6 pieces of data, so the average would be the middle, because the middle would be right here, 3 and 3. So the average there, or mean of 4 and 6 before plus 6 divided by 2, which is also 5. And the mode for this set of data would be 6. And then in part B, we're asked to calculate the range for each group. And the range for without, I'm just going to say WO, without compost, the range would equal, the highest was 8, minus the lowest was 3, so that would be 5. And for with compost, the highest was 11, so the range equals 11 minus 1, which is 10. So it says describe the dispersion in the data for each group. So if we look at both those, the range for the with compost spanned over many more numbers than the range with without compost. So if we describe dispersion, it seems like the data values for with compost are more spread out. than without compost. And which group of plants grew better? And again, you kind of have to look at all the data. Like they both had the same mean. Median was close, 4.5 for without compost and 5 for with compost. And they their mode though was a little bit different. The mode for without compost was 4 and with compost was 6. And the range was also different. The range without compost spanned over 5 values, whereas the range for with compost spanned over 10 values. So when we kind of look at which group of plants grew better, there's a couple of things you can kind of consider there. But I kind of, when I'm looking at the data, I'm thinking that the without compost seemed to grow a little better because there weren't any real low values as there were in the with compost. There was values of 1 and 2 in with compost, whereas the lowest value in plant growth without compost was 3. There was a real high value in the with compost of 11, but you know, in terms of the data, overall data, this data here seems to be a little bit more consistent, and it also seems to be more, you know, typical, whereas the data with compost had just one real high one, but the rest were lower. A couple of them were actually lower than the lowest one in without compost. So if I had to pick a group, I would probably say the plants without compost seem to do better overall. Since there weren't any real low values. And all data was greater than or equal to 3. Whereas with compost, only one real high value. There's only one really high value of 11. And 2 values less than 3. So again, you could probably justify, you know, it depends on what you're looking at in terms of the best growth, but if I'm looking at the overall picture, I would say that the ones without compost seem to grow a little better. Alright, question number 2 says to determine the range of each group. So if we look at group A, we have the range equals, looking at these sets of data, both of these sets of data are in numerical order. So the range of the highest is 20 and the lowest is 8. There's a range of 12. And in the second set of data, the highest is 18 and the lowest is 7, which is a range of 11. So in this case here, the range is similar. For both. Sets, but in the first set, so it looks like they're both evenly spread out, but when you look at the first set, most data is in the range of 13 to 15, with 8 and 20 kind of being outliers. Or kind of outside the rest of the data. There seem to be kind of unusual pieces of data for that set. So when you look at it, range is similar for both sets. When the first set, you know, the data seems to be pretty clustered around 13 to 15, whereas in the second set it is kind of spreading out over the 11 data values from 7 up to 18. Okay, so that's it for that section. There's some questions there on pages 239 to 240 of your text that you can try, and just notice that in question 1 you don't have to graph the data. In question 1 you can just answer the questions.